Okay. Questions related to work, energy, and power. MCQs first for discussion. Energies release some nuclear reaction. Which nuclear reaction take place in a nuclear power station and which take place on a sun? What is the answer? Everyone should participate, so it shows your understanding of the topic. It's not an issue even your answer is wrong. Don't bother about the wrong answer, but you should participate to show your understanding. Yeah, B is the right answer. Power station fission and sun or stars fusion occur. Question 2. I think this we did, but we'll do it again just for a revision. What could be the answer here? The kinetic energy of the lorry is same as the kinetic energy of the car. Yes, C was the right answer because the kinetic energy of the lorry is half mv square and kinetic energy of the car is also half mv square. So it's half mv square for lorry or a truck. Both have the same kinetic energies. And kinetic energy of the car is also half mv square. You will substitute the mass of the car, mass of the lorry, speed of the lorry, and find the speed of half will cancel with half. So you can work out with the calculation. C will be the right answer. Then a force act on an object cause the object to move to certain distance. Which row represent a situation in which the largest amount of work is done on the object by the force? So work done is force into distance. So C is the right answer. Question number 4. A box of mass m slide down a slope of length L and a vertical height D against the frictional force F. Which row gives the loss in potential energy and the work done against the friction? So loss in potential energy, because potential energy is mgh. So mass into gravity into height. The distance is height is d here, and the distance which move along the track is L. That's why A is the right answer. Now in this diagram, the diagram represents the energy transfer for a device. The device is 50% efficient. Means half of the energy is wasted and half of the energy is useful. What is the right answer if it is 50% efficient? Which one you're saying why it is not B? You're asking about question 4 or 5? In question 4, why it is not B? Because what you did, the friction is not acting vertically, friction is acting on the plane, on this surface. So when we calculate, because the question is the work done against the friction. So work done against the friction or by the frictional force will be same. So the direction in which the frictional force is acting is along a distance L. That's why the work done by the frictional force is F multiplied by L, not F multiplied by D. If a person was lifting, like example, if there was a person and he lifted, then the work done will be F multiplied by D. Is it clear? So 5, the wasted output and the useful output will be same. So that's why C is the right answer. Now in this question, a student carries out some simple exercises in which exercise is the most work done. So most work done, how to calculate a work done when you are lifting an object? So work done is force multiplied by distance. What is the force I will apply when I'm lifting a 1 kilogram object? How much force I have to apply? Kilogram is a mass. To lift an object, how much force we have to apply? That's equal to 10. So force is 10 multiplied by distance which we move. We move a distance of 1 meter, so it's 10 multiplied by 1. So that's equal to 10 joules. So work done for A is 10. But what about B? When you're pushing the object horizontally, the weight affects the frictional force, but it does not, like example, it's not necessary. If this object is now 10 Newton, you don't have to apply a 10 Newton force horizontally. It depends on the texture of the surface. How it is 10? Because the mass is 1 kilogram, mass is the amount of matter, but weight is a force of gravity, so the gravitational force is 10 Newton. So to lift an object, minimum force to lift an object should be 10. It will be practically more than 10, but minimum force will be 10. Whenever you are lifting an object, the minimum force required to lift an object is always equal to the weight of the object. In this example, an object is there of mass 1 kilogram and you are lifting this object up. So if mass is 1 kilogram, what will be the weight of the object? What is the weight of this object if mass is 1 kg?
It'll be 10.
10. So it's 10 Newton object. How much force I have to apply to lift this object? I have to apply more than 10 so that I can raise this object. If this object is on the ground, so I have to apply more than 10 to raise this object above the ground. So minimum I need 10, I need more than 10, but the minimum value of the force should be 10 to lift this object up. And we have to apply a force of 10 Newton minimum, and we want to move to a distance of 1 meter. So it will, what is the work done? Work done is equals to force multiplied by distance. So force is equals to 10 and the distance is equals to 1. So 10 multiplied by 1. What is the work done in A? The work done in A is equals to 10 joules. Is it clear for A?
Yeah, it's clear now.
But when you are moving the object horizontally, you're not lifting the object. So force, the weight affects the frictional force, but it is not having any relation with the force which you have to apply. It depends on the texture of the surface. It depends on the frictional force. So you are applying a force of 4 Newton to move the object 1 meter. So how much work is done here? When you are moving the object horizontally, you don't have to bother about its weight. So it will be 4 multiplied by 1. So 4 multiplied by 1, it's equal to 4 joules. So moving it horizontally, weight will affect, but not too much. The force required to move the object is not necessary. That should be equal to weight. It can be more than weight. It can be less than weight. It depends on the texture or the friction between the two surfaces. So when you're dragging the object, when you're pushing the object, you don't have to bother about the weight of the object. Is the force which you applied and you move the object to certain distance. So force you applied was equals to 4 Newton and the distance you move is 1. So 4 multiplied by 1, that's equal to 4 joules. So work done is 4 joules for B. What about C? Again, you are lifting an object. So how much force I need to lift this? The weight of C is 20 Newtons. So minimum force I need to lift this object. What will be that force?
40 Newton.
40 joules will be the energy. Minimum force I need, it's equal to 20 Newton. And when I calculate a work done, so work done is force multiplied by distance. So it is 20 multiplied by 2, which is equals to 40 joules. So I have to apply 40 joules for C. What about D? We don't have to bother about its mass. We are applying a force of 2 Newton and we are moving 2-meter distance. So 2 multiplied by 2, that's equal to 4 joules. So which one we did the most work done? So C was the right answer. So when you are lifting the object, the force which you need is equals to weight of the object. When you are dragging the object, it is not necessary that the force must be equal to weight. It can be less than the force, the weight.